All right, here's 2.6, day 1, part 3. This is the last example we'll do, and it will have a slant asymptote. So we have another rational function, and we want to find the pieces. So now that you have all those steps in your notes, maybe this problem you don't want to be so specific. Just go step 1, domain. Step 2, vertical asymptote. Just call it VA for short. Then step 3, HA, which is your horizontal. You have all the steps. So this might move a little faster now for us. So we have our polynomial in the numerator. And we have our polynomial in the denominator. So we'll start with the denominator. And we'll find out what the domain restriction is. So we set the denominator not equal to 0. So what will be our domain here? All real numbers except for what? The domain, the denominator. X minus 1 cannot equal 0. So then x cannot equal 1. So the domain then is all reals except x can't be negative, x can't be positive 1. So then what would be your VA? You want to use the VA for short? What would be the vertical asymptote then? X equals 1. So this uses VA for step 2. Let's go on to HA, horizontal asymptote. Now we're looking at the degrees of the numerator and the denominator. What is the degree of the numerator? The degree of the numerator is 2. The degree of the degree of the denominator is 1. So if I go back to that first set of rules, right here, if the degree of the numerator is greater than the degree of the denominator, then you don't have a horizontal asymptote, but you must check for a slant. And here's what a slant is saying. If the degree of the numerator is exactly 1 more than the degree of the denominator, in this case it is, then you have to use long division, ignore the remainder, and whatever you get as your answer will be your equation for your line. So it might make more sense once we get to the showing you how to do it. Okay. So we'll go back. So do you agree with me that it's 1 more than? So we do not have a horizontal asymptote. Because the numerator is greater than the denominator. But there is a slant because my degree of my numerator is exactly 1 more than its denominator. So we're going to use long division. And we're going to divide the denominator into the numerator. So we're going to divide x minus 1 into x squared minus x minus 2. This is another reason why we had no long division. All right, so let's go ahead and divide. How many times does x go into x squared? X squared divided by x. X. Now we multiply it. The 2 terms in front. X squared minus x. Now we change the signs. Negative, positive. First set of terms cancel out. Second set of terms cancel out. We bring down the negative 2. Can you divide x into negative 2? No. So this is my remainder that I ignore. I don't really care about it. So what your slant asymptote will look like is whatever this is. Y equals x. Whatever's up on top here is what your slant asymptote will be. And it'll be in the form of a line equation, in the form y equals mx plus b. So, or y equals x plus 0, where this is going to be your slope, and that'll be your y-intercept that we'll graph later on. Now we're going to go ahead and find the zeros of the numerator, which will help us to find the x-intercepts. So we go up to the numerator. That polynomial was x squared minus x minus 2. And we find the zeros. So when we find the zeros, we try to factor it. Find x, in this case it's a quadrat, so we can factor this using the chart method. What are the factors of negative 2 that add to negative 1? Negative 2, positive 1. So then the zeros would be at 2 and negative 1. I want you to write those as ordered pairs. So then the ordered pairs would be 2, 0, and negative 1, 0. Step 5, y-intercept. So there was our, let's rewrite the function again. Y equals x squared minus x minus 2 over x minus 1. And we substitute 0 into the function for x. So 0 squared minus 0 minus 2, 0 minus 1. So reduces it down to negative 2 over negative 1, which is 2. So you have a y-intercept of over 0 up 2. And then we test for the symmetry. So those rules are there again. So let's substitute negative into the function. If I look over here to step 5, do I get the original function back? No. If I substitute negative into the function, no, and no. None of those work. Just to give you a heads up. None of them work. So I have no symmetry to help me out. Now I'm set to graph everything that I have. So go ahead and make an XY plane. Now I just start from the top. Where are the vertical asymptotes at? At x equals 1. Where is the horizontal asymptote at? There wasn't one. So I go on to the slant. The slant was at the equation y equals x or y equals x plus 0. Where again, this is my slope, that's my y-intercept. So I graph that line. So we start with the y-intercept of 0. We do the slope. Rise 1, run 1. Rise 1, run 1. This is also called the identity line when we're dealing with inverses. And then identify that as y equals x. So there's your slant. Where were the x-intercepts at? 2, 0. And -1, 0. Where was the y-intercept at? 0, 2. So let's start on the left-hand side. These 2 green dots. What do you think is going to happen above that slant and to the left of that vertical? What do you think is probably going to happen? A curve, yep. I help guide that curve. And what do you think is going to happen with that one x-intercept over here? Another curve. Guides along those asymptotes. And there's your graph. No additional points needed. What my plan is for tomorrow is, there were some students that were gone today, is to maybe do one more problem, either maybe from your homework, or I have more examples on this SMART lesson that we could practice, either maybe just finding the slant asymptote again, or, so we'll keep it to what you guys think you might want tomorrow. This is your homework, 5 through 11 odd, 25 through 27, and then 29. I'm not teaching a new lesson tomorrow. It's essentially going to be like a work day. Either you continue working on this assignment, or you start working on the review. Then Monday, we're going to work Monday as a review day, and then Tuesday we'll take questions, and then Wednesday will be our chapter test. Remember, tomorrow we're going to turn in the 2.5 homework.